Hey guys, Chris, the Industrial Electric. Today we'll be doing core loss. And what core loss is, we're checking for the pounds of wattage of loss. In order to do that, we need to take accurate measurements of the core, the length and the bore diameter, the tooth width, as well as the back iron measurements. In order to do that, we will be taking our tools here. We'll start off by getting our length and our diameter here. Now we'll be taking the back iron and the slot depth as well. These are a little difficult while the winding is still in there. So we have to get as close as we can. With the winding being in there, it's not going to be quite as accurate as we'd like it to be. In order to get the slot depth and then the back iron, you take your slot depth, you will zero it out, and then you'll continue to go back to the back iron to the back to help you get a better measurement of your back iron. Since these ones are small, they're going to be a little hard to get into. Some of these do have air gaps on the back, so you do have to take a couple measurements and get a average. And then we'll get the tooth width. This one's a little bit difficult on these smaller teeth, so just make sure you take a couple good measurements on there if you can. Typically just line up on the inside to the inside there. So make sure you get as accurate as you can. Okay, now we got our measurements here. Add our information from our motor, customer information onto our sheet here, so we can put it in the computer to test to make sure that our watts are where they should be. We want to make sure that we're doing that because the insulation over time, depending on the application, depending on where it's at, will lose the insulation life a certain percentage due to environment, due to stress. So the main test here is just to make sure that that insulation is still good. Eventually that insulation will fail to where you can have a failure in the slot inside here. It can create hot spots, which will get to the bearing at some point and can create bearing failures due to the excessive heat from the insulation failures. So it's very important to make sure that these percentages aren't too high, so that way the motor stays at its efficiency where it should be. So now we're gonna run this tester through. This here will run from one side back into our 12.5 volt side. Depending on the size of the motor, the core, depends on the voltage that the computer wants to see. And this here is going to be making sure you're going the correct way so it can read the watts through this one here. So if these are going the wrong way, not following the correct way, it will not read for you. So that can be something to make sure that you will do correctly on that. Now let's enter some stuff in real quick and we'll test it. Okay, here on our computer, it'll show us what we want to be in the range of our target flux. Gives in kilo lines where we want to be on our voltage. And it tells us what the marginal and the maximum the core loss watts per pound is. So we want to be between 6 and 10. And this one is 2.9. So this one is a good working, it's under the 6 marginal. And we definitely want to be between the 6 and 10, but this is under, so it's definitely a good insulated motor still. So what we're doing now is a hot spot, bringing up our amps. What we want to do is generate enough amperage in there to create any extra heat in there. So we have, here's our fluke monitor. We're going to be checking for hot spots as soon as we run it for 90 seconds at their correct amperage. It's creating that flux in there. This is heating up the core and heating up the insulation. So it'll show any hot spots in there that could be failure of insulation inside the core. And that'll be something we mark, and that's something we're gonna want to have to keep on our job sheet. We want to make sure we take pictures and stuff like that, just to make sure any time in the future, if it does have any problems, we'll know where it indicated. So. All right, so now we check the core. It'll show us degrees here. Right now, this one is at 54.7 Fahrenheit. So just want to make sure we go through the whole thing. This is a good motor. It's got low watts per pound loss and 0 hot spots. So after we test and everything's good, we will put it in our dip varnish. It will sit in there. After that, we will cook it for 4 hours in our bake oven. After that, that's pretty much it. That's all we do over here.